And I'll post the links to the video soon, okay? Today. All right. So go ahead and get your flaw file and your AS file. Remember that your game should be working up to this point. And then we'll review our code. All right. Do we need to get the lights? Should we get the lights? Might as well. So we can see our screen a little bit better. All right. Remember that when you have your flaw open, the file, the AS file that it's connecting to, if you click off of everything in your properties panel for your flaw file, you'll see the class and the class name. And to always make sure that you're connecting to the right file and that it's connecting correctly, whenever you go to open up your AS file, you can just hit that little pencil icon right here. It'll ask if you want it open in Flash Professional Builder. We'll just open it in Professional. And then you'll make sure that you have that same AS file. And if they're stored in the same folder, it should find that same AS file. Okay? So make sure that you have your AS file and your flaw file open, and we're going to go through this code. In fact, does anyone need help getting those open? Everyone has these files? All right. Now remember, as we go through this code, you can add more comments than what I have, okay, because this is a coding class. We do need to understand what we're doing in here, okay? All right. Remember what these statements up here do. What do these statements up here do? Our import statements. You guys remember what our import statements do? Yeah, they let you use all these different classes and reusable code. Okay, when we're programming any kind of programming language, we like to use reusable code. It lets us, our movie clips move across the screen. It lets us use those click events. It lets us check, and have that enter frame event. So remember that our import statements are our libraries that we're importing. Okay, so these are our libraries that we are using. And these are the class names, and we can tell they're class names because they're capitalized. Okay, and these are folder names because they're lowercase. And then we had the main part of our program here, the public class, and then this name here had to match the name of our file. And it extended a movie clip. That's a little bit of inheritance, but that's so we can use all the movie clip things like playing and stopping. And remember that when we're making our classes, we make our instance variables at the top, and we usually put our characters, or we can put our score up there, or we're going to put a vector of carrots up there today. Okay? So we put our instance variables at the top. And it's customary in a lot of programming languages to make them private, so we followed that practice and made them private. And we declared them at the top. Remember, that's called our declaration. And then down here is where we instantiated them. We learned that term last week, instantiation. It's where we created them with the new operator. So to add anything to the stage, first you create him. Then we set his X and Y so he wouldn't appear in the upper left-hand corner, remember. And then we had to add him to the stage. And that's how we always add anything to our movies. And remember, we made this gravity. We made this variable gravity so that we could add some Y values to our bunny to make him fall down. Okay, so this was a variable that we used. And we usually group our instantiations together, our variable initializations together, and then we usually group our event listeners. And we had 2 event listeners. Remember that the first event listener we implemented was our click event. That was to listen for when we hit the mouse, and then when we go to our E-pads, it'll be when we hit our finger on the E-pad. And we added it right to the stage so that they could click anywhere on the stage. And of course, our listeners always work the same way. They listen for this event, then they call that function. We should be getting pretty good at this, okay, knowing how these work. Okay. And our public function we wrote here, we had to write it separately. And remember that we added some values, or we gave gravity a value of -10, so we, set him back a little bit so that he won't be falling down so much. And then our y value for our bunny, which is our vertical, we subtract 35 pixels, and that made him go up. So that made his y value go up. Okay? Remember the gravity was to make him fall down, so if it's -10, he won't fall for at least 10 more pixels. Okay, going down. It actually makes him go up a little bit more. And then importantly, in all of our games we're going to use this, we had to have a kind of a timer or a clicker, because that's how event programming works and GUI programming works. We had to have this timer. And so we just used the on-frame enter or enter frame event. Remember how many times a second that guy gets called? Or gets triggered, gets fired? Yeah, 24 times, because that was our frames per second that we had in the stage. Okay, so, if we have our stage set to 24 frames per second, then that event gets called 24 times a second. Okay? So it's important to understand those. And then in our on-enter frame method, so that's the method we call here, the function we call. And this was the last function that we wrote, okay, before we, stopped. Let's see here. We added to our y value. Remember there's two ways that we could write this, but this was the more efficient way to write it. And we added 1 to our gravity and then added it to his y value, so it makes him go down, because the positive y value is down. And then we notice that he falls down really quick because that gravity is increasing 24 times, 24 pixels per second. So we put this branching statement here to kind of stop gravity at 20. So when it reached 20, it would stay at 20. Okay, you guys remember why we put that there, right? And then your job was to play around with the numbers and change your character last time. So what we want to do today is we want to give the illusion that the bunny is actually moving. So the first thing we're going to do is we're going to add our background. We're going to add a background and have the background move across the screen. And it'll appear like the bunny's going forward, but the background's really moving backward. Okay, so we're going to do a little bit of parallax scrolling for our background. And then we need to add our carrots, or some kind of obstacle. You don't have to have carrots, but I've used carrots for our obstacle. And so we'll have to listen for the event for the bunny to hit the carrot and add that event listener to our code. So when it hits the carrot, we can tell it to die. Okay, so you can play his death scene. All right, but let's make our background first. Now when we're making the background, to give the illusion that the background doesn't skip or jump, we're going to make the background twice as wide as our stage. So, the background's going to be twice as wide as our stage, and it's going to move this way, and when this part of the background gets to here, it's going to loop back. Okay, actually let me pause it. All right, so in this example here, I just dragged those buildings out. Now we're going to add the buildings through our code, okay, but I just dragged them out to the stage so you could see. And we made this background here, okay, and then I just copied and pasted it here and we glued them together. Because when we play this, this is how it's going to play. This is going to scroll, 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 scroll. And when it gets back here, it's going to go back to frame 1 and add it again. And it's going to scroll, 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 scroll. And then it'll jump back to this position. You see how it'll jump back? So this part has to look exactly like this part, otherwise it looks like it jumped. Okay? So what we're going to do is we're going to make this part, and then we'll just copy and paste it here. Okay? And you could actually make it longer, but you just have to remember that your first part has to look exactly like your end part, so it won't look like it jumped. Okay, but we're just going to do it simply by making, one to fit the stage, and then we'll copy and paste this part, and then we'll group them together. Okay? All right. I debated whether to give you this, but I think it's a good learning experience to learn how to do, this background. So that way you can redo your background with a different background if you want. Okay, you won't be stuck with the buildings. Buildings are pretty easy because we're going to use the spray can tool to spray the buildings on. Or the Art Deco tool. Okay. All right. So let's go to our flaw. And we're going to get our Art Deco tool out, which is, where is he? He is, there he is. Actually, the Deco tool right there. All right. And actually, in Flash Creative Cloud, they got rid of the Deco tool. I was so sad. So if you have Flash Creative Cloud, you're going to have to draw your buildings. Or actually, I can give you the buildings. I'll put the buildings on Blackboard so then you can have some buildings. Okay? Yeah, it's so disappointing. I was like, what happened to the Deco tool? Yeah, and they took the spray paint can away. It was so sad. I love the Deco tool. Well, anyways, the Deco tool is this pencil with some magical sparkles around it. And if you click on the Deco tool, over in the Properties panel, it shows you, the Deco tool. And I'm not sure if we experimented with this tool before. I can't remember. But you can experiment with it and then Control-Z and undo if you want. But just know, okay, so here's what it's going to fill it with. So right now it's vine fill. It's kind of fun. You click it on something, it fills it up with some vines that it draws. Kind of neat. Remember, Control-Z and undo that. Okay. But if we click the Art Deco tool, there's all these cool tools, or cool fills that it has. And one of them is the building brush. One that I really like too, maybe I'll show you really quick, I don't know if we showed this one, is fire animation. It's pretty neat. If you click on fire animation, it actually makes a frame-by-frame animation of some flames. Remember, Control-Z and undo that. But, yeah, fire animation's cool if, you wanted to show, something blowing up. I don't know. I think that one's kind of cool. But the one that we're going to use is the building brush, so let's choose building brush. I'm going to zoom in a little bit. So Control plus to zoom in and Control minus to zoom out, remember. Okay. All right, and then you just take your building brush, and you might have to practice this a couple times to get it. But pretty much you can hold down your left mouse button, and you can make your buildings. Oops, I already messed up, so let me undo that. Okay. And if you get them a little bit outside of the stage, don't worry, we're just going to tell them. And it just does random buildings. Okay. And you can edit these buildings after. Okay. But I'm just holding down my left mouse button, and then I'm scrolling, or I'm pushing my left mouse button up to draw some buildings. And you can draw them different sizes. Oops, I made one kind of up here. It's just a fast way to draw some buildings. These aren't coming out as great as my other ones, but that's okay. And I just made them, you know, almost fit the stage, and then I'm going to force them to fit the stage by changing their size. Kind of a fun tool, right? If you're like an artist, you just draw the building, click the mouse. So if I wanted to edit those buildings, you could just click on the building and edit part of it. Like if you don't want them to have like those antennas, remember that you can double click on parts of the building. It is just a drawing object, and you could edit them. Remember to keep track of where you are up in the upper left-hand corner, so when you're double clicking on these things. Okay. What I did is I just double clicked on part of the building, you know. Then you can, I don't really like all those antennas sticking off, all of them. Or maybe those are lightning rods. I don't know what the heck they are. And you could go in there and edit the colors and things if you wanted to, or put little people in the windows. Just kidding. And remember, you don't have to have this background at the end, but I thought we'd just practice this with this one. Cool. I'm going to pause this for a second while we're working. All right. All right, so if you got a picture in the background, or in our case, we just have some buildings in our background. First, note how big your stage is. So our stage, if you click off of everything, you go to your properties, you can see the length of our stage, or the width of our stage, is 840, okay, by 600. And actually, you know, I forgot to draw. Let's draw some clouds up here too. I'll show you how to draw some clouds pretty easy with our oval tool. We'll just make a couple clouds. So let's choose our oval tool over here on the right. It's actually pretty easy to draw clouds with the oval tool. So remember, your oval tools might be underneath your rectangle tool. And just make sure your fill color is white, or whatever color you want your clouds. You could have gray clouds. And the way I usually draw clouds is I'll draw an oval. So clicking and dragging, and then I'll draw an oval kind of overlapping it, and an oval on the top kind of overlapping it, and it kind of makes a cloud. Okay. Of course, if you guys know how to draw better clouds, okay, but that's usually how I draw clouds with the oval tool. And I'm just going to make a couple of clouds. Maybe I'll make this one a little bit bigger. So that looks pretty good. All right. So now what we're going to do is we're going to group it all together. And then, like I said before, we're going to copy and paste it so it's two versions of the same thing next to each other. And then we'll group that one together, and then we'll make it into a movie clip. So the only things that should be on your stage right now is the clouds and the buildings, or whatever you have as your background. So if I do a Control A or select all, it selects everything. And I can do a Control G and group it together, and you can see that it makes a blue outline around it. Now it's a single object. So now I'm just one object. And now I can look at that as one object, and I can look at its properties over here on the right, and I can make it exactly the right size that I need. Okay. So our width was 850 pixels, so I'll choose 850 pixels. Was it 850? Yeah, I was going to say it's a little bit bigger than my stage. Oh, my stage was 840, so that makes sense why it was bigger. Okay, 840. Now it doesn't matter if it's starting in the right place because I'm going to actually add this through my code. Okay. I guess it will matter where you put your Y value though. If you put your buildings where they don't reach the top there, I will want to take note of where my Y value is. My X value, I'll start at 0, but my Y value, if I want my buildings not to show the bottom of them, or I could put another image down here like a road or something. But if I want my buildings to start like this, where they're kind of hitting the bottom of my stage and you can't see my my excellent drawing skills where I have all these gaps. I guess I could edit them, but I can make sure I put that Y value in when I add it in my code. So if I put my Y as 113, then they will show up like this in my code. So remember, we're going to add these through our code. Right, so we grouped them. We made them the correct width. Now we're going to copy and paste them. So we'll do a Control-C, Control-V. So I copied and pasted it. I might have to zoom out, so Control-minus to zoom out here. I'm going to put these buildings right next to them. I want them to be at the same Y value. So 113.85 is my Y value, so that way they're not going to, jump up. I notice that my X value for my second one is at 840, so it's at the correct place. Okay, so make sure your X value is exactly at the edge here, so it should be 840 of your second set. Your copy and pasted set, his X value should be 840, and then his Y value should be the same. So that way it's right next to him. And then all we have to do is do a Control-A, or select both, and Control-G and group those. So I'm going to do a Control-A, it selects everything. I'm going to Control-G it again. And now I got one blue line around all of them, so now it's a one object. And that will be my building's background object. So we do want to add him through the code. We want to animate him. So we got to make him a movie clip. So after you group them together, you can hit the F8 key and make it into a movie clip. Remember to name your movie clips with a capital letter. Start them with a capital letter. And then remember to check mark that box, Export for Action Script, so that we can add them through our code. So remember, just hit the F8 key. So have your building selected, hit your F8 key. Alternatively, on Macs, you have to right-click, say Convert to Symbol. Right? We name it with a capital letter, and then Export for Action Script. And then he'll show up in our library over here as a movie clip. Of course, we always say yes, make that definition. He'll be over here as our buildings object. And now we can delete that instance from the stage because we are going to add it through our code. Remember, that was just one instance of our buildings. Okay. So now we're going to go to our code file, and we're going to add our buildings to our code and get them to scroll across the screen. Okay. So remember to open up the correct AS file, and to always make sure you have the correct AS file, remember to click on that pencil icon. So then you have the correct file open. All right, and we're going to do the same kind of methodology we did before. We're going to add it as an instance variable up here. In fact, I'll even put a space there so you can see it better. but normally I would put them right together. So I'm going to declare him a type variable. I named him BG for background. A lot of times people do name their backgrounds BG. Okay, it's kind of a common programming practice, name background BG, but you can name it background if you want, or you can name it some other name. Just remember, when we name our variables, it's always with a lowercase letter. So our variable names are lowercase. And then you put a colon, and then you put your type that you just built, that movie clip you just built, so he's going to be an instance of that movie clip. I named my movie clip buildings, so that's what I put right there. And then what's our next step? First we declare him, then we instantiate him, right? So first you declare him up here, and then we instantiate him in our constructor. Okay, so first we declare him. Then we come down here and we say, okay, building, let's build you. And we can build him right after we built our bunny. We could say, okay, you equal a new instance of type buildings. We can set his X and Y. Remember, we do the same thing that we did for our bunny. So we set his X value to 0, which it is by default anyway. And then we set his Y value. And I remember my Y value, sorry, was 113. And so I put my Y value is 113. Remember, that's our vertical value. How far down on the stage he'll appear. And then importantly, we have to add him to the stage, otherwise he will not appear. So we do that with the add child method. And we tell it to add a child of our variable BG. And that should add him to the stage. And we could test it right now. Of course, he's not going to be scrolling across the stage yet. We haven't told him to scroll yet. But we can see that he's been added. So remember, you save your file first. You always have to save your AS file, so Control S. And then you can do a Control Enter. There's our bunny. Our bunny is behind our buildings. We need to make him in front of our buildings. Actually, there's a couple of ways that we can make our bunny in front of our buildings. What's one way you guys can think of? Now, when we're adding things to the stage, it's adding it to a new layer, always in front of each other. So one easy way is we could make this code come before the other code. That would add them to the back. Okay? So we could write this code before our My Bunny code. We could copy and, or cut it and paste it up there before our bunny code. That would make him in front of our bunny. I mean, in back of our bunny. Or we can use another method called addChildAt, which it's good to know this method anyway. And the addChildAt method adds our child at a specific index. So when we're adding things to the stage, it gives them index numbers, like an array. You guys know arrays are vectors. And we could tell them to add it at index 0, which would be the very back of our stage. So you could tell it to add it at a specific index as well. And you can see when we add him at index 0, he goes to the back also. So either way would work. You could put this code in front of the My Bunny code. Remember, that way works. It adds it in layers. It's good to understand how it adds it in layers. Or use this new function, addChildAt. It has 2 arguments. The first is what you're adding. The second is where or what level you're adding it at. So if I add them at index 0, that's the very first index. Our indexes always start at 0. In almost all programming languages, your indices start at 0. That's how computers work. So 0 is the very first one, so he'll be on the very back layer. Does that make sense? So now we just need to get him to scroll. So once you get him to appear, so make him appear first. Test as you go. Control S, Control Enter. Make sure it appears. Okay? And I'll take a break in a second, but let's get him to scroll first. I bet you guys can think how to make him scroll. How do you think we're going to get him to scroll? Right, we just increase, or actually decrease his x value. If you want him to scroll this way, increase his x value if you want him to scroll this way. Okay, so negative x goes this way, positive x goes this way. And so we have this timer event. This is why this timing event is very important to our program. We already have a timer that's clicking for us, 24 times a second. So we can use this timer to add to our background's x value, or subtract from our background's x value. And check when it gets to a certain point, we want it to start over again, right? All right. So that's where we're going to put it. We're going to put it inside of this function. We're going to put the logic to make him move inside of that function. Okay. So we'll come down here to the on-frame enter event, and we can put it after the gravity. It's fine. And we could say, okay, BG, your y value, let's add to it. So we'll do a plus equal. And we could plus equal 1 pixel every time the function's called. So that will be 24 pixels a second. We could try this out, and then you could play around with this number. Okay, and you should, actually, we should do minus equal, I wasn't even thinking, not y value. Well, you could try the y value. The y value will make it go down. But it should be our x value, because it wants to go this way. And actually, it's good to play around with this a little bit. And this will be a minus equal, actually. You could do plus equal to try it out. It doesn't hurt it. And then you can do a minus equal. And remember, another way to write this, so it's good to know what this code means. So this is another way to write it, so you can realize what it's doing. Remember that it's taking the old value of our background, dot x value. So it's taking his old x value, subtracting 1, and then putting it back inside of that x value. Now I wanted you guys to kind of play around with that a little bit, so we'll do a Control S, Control Enter. You should see the backgrounds moving. Now they're moving really slow because I'm only adding 1 or subtracting 1 pixel every time the function's called, so it's only subtracting 24 pixels per second. That might be too slow for our game. In fact, you can even think in higher levels, you can make this a variable and have it go faster at the higher levels. You guys kind of see that? Like you could have level 1, it goes slow, and level 2, it goes a little bit faster. Okay. But yeah, so 1's probably not the best number to put there. You could put like 10, try 10. And you should see the background going by kind of faster. Now notice that when our background runs out, we're not telling it to go back to the beginning, so he runs off the stage, and he just keeps going. When does he stop? He doesn't stop. He just keeps going. Off into virtual world over there. Okay, so now we need to add the logic to make him stop and replay. And I bet you guys could figure that one out too. In fact, we're going to put it right here. We'll put a branching statement. So here's where we want to put some logic. Right? Now notice I did do a factor of 10 or an even number, and I didn't do an odd number, because if we do an odd number right here, it will look like it jumps a little bit. And you can kind of think about why that would do that. Or a number that divides into 840 evenly. Okay. So like factors of 10 work well. All right, so here's where we need to put our if statement, our branching statement. We need to make a check right here. And we need to check his x value. And what should we check for? If it's less than what? And let's think about what it's doing. And you guys don't have to do this part, but I just want to show you. So our buildings are going to scroll across, right? They're scrolling, 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 scrolling. And when they get here, we want the x value to jump back to 0. And then it'll scroll, 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 scroll. And then when it gets here, we'll jump back to 0. So what will his x value be when he's here? What will his x value be? Now his x value started at 0, and then we're subtracting. We're subtracting his x value. Remember, his x value is to the top left-hand corner there. Oops. So when we do x values, they're in reference point to wherever the crosshair is. And our crosshair happened to be in the top left-hand corner because we left it by default. So his x value is 0 right here. Yeah, there you go. I heard Alan say it. So you kind of think, well, what is his x value right here? Hopefully everybody realizes it's negative 840. Because this is 840 wide. If we moved him off the screen, well, actually the whole thing is 1680, right? So when 840 pixels of it gets over here, that's half of it. He'll be at negative 840. When he's negative 840, we switch him back to 0, his x value. Okay? And that'll give the illusion that the buildings never stop. Okay? So we'll say, okay, if you're less than 840, so when you become 840 or 841, actually I think we'll have to put less than or equal. Actually, just less than, right? Then we'll go ahead and switch his x value back to 0. And with that little branch right there, that'll check to see, okay, have you reached this point yet? If you have, go ahead and switch him back to 0. Next time around, I'm scrolling across again. And notice that we did less than because we're increasing in our negative values. He'll be more negative when he gets beyond that point. So we should test him. Oh, and I left some on my stage, so I have some buildings I left on my stage there. And notice that 10 pixels makes him move pretty quick. And you shouldn't see any kind of jumps or anything. When he reaches that point in your stage, he should switch back and if we tell it to render with the GPU, it will look more flowing too. All right. So let's make sure everybody got that to work. Now, so I just want to give you a heads up of what we're doing. This will be our first data structure. And if you've been reading in your book, you would have read about our data structure called a vector. And you can think of a vector as a box holding a whole bunch of the same kind of objects. Okay? It's kind of like a container where we're going to put all of our caret objects so we can treat all of our carets as one object. Because we're going to need a few carets to come into the scene. And so, we're going to need to create them, but to hold them all together as a single unit, we're going to use this thing called a vector. And we'll write this code, but just listen for right now, okay? So we're going to create that vector object. This is how you create a vector or a container. Okay? So that's how you declare a vector object. And then when we create our vector object, we're going to have to use something called a loop. We haven't actually discussed loops in here, I don't think, not yet. So this will be our loops. Okay. The way that a loop works, loops are the same in every programming language. So once you learn how a loop works, you can go to any programming language and use it. This is called a for loop. A for loop has 3 parts in its loop, and they're separated by these semicolons. Okay. The first part of your for loop is called your initialization action. Okay, it's this part of your for loop right here. It's your initialization action. This part of your for loop happens one time at the beginning of your loop. So a lot of times when we make loops, especially for vectors, we'll make them the same way. And we'll use this variable I as an index in our vector. An index means, like, we have a container to hold all of our caret objects. Each of those caret objects is given a number. It's called its index. And we start counting our objects with 0 because that's just how programming works. Okay, we always start counting with 0. So all of our vector objects will be named numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like if we have 10 carets. And we're going to put 10 carets in there. Or 10 objects in our vector. Okay. So this initialization action sets that index to 0 for us. And it only happens once at the very beginning of the loop. That's why it's called the initialization action. Okay. Now this middle part of our for loop happens on every loop iteration. So every time the loop happens, this little Boolean checks to see if we're going to execute the loop one more time. So it'll check at the beginning of every loop and make sure that we're less than 10, that our index is less than 10, our variable I is less than 10. Okay? So if it's not less than 10, and that's false, it'll go out of our loop. But if that's true and our I is less than 10, it'll execute our loop from the top to the bottom. Okay? And then the last part of our for loop there is called our update action. And this part of the for loop happens at the end of every loop. So the end of every loop iteration, we add 1 to our index, or add 1 to I. Okay? So how many times is this loop going to happen? So every time this loop happens, okay, the first time it sets it to 0, then it checks to say, hey, is 0 less than 10? Yes, it's less than 10. It makes a new caret, puts that new caret in our vector, comes back up here, adds 1 to our I, so now our I is 1. It checks to see is 1 less than 10. Yes. Makes a new caret, puts it in our vector, comes back up here, adds 1 to I. I is now 2. Is 2 less than 10? Yes. Makes a new caret, puts it in our vector, comes back here, adds 1 to I. So how many carets are we going to end up with? It keeps doing the same thing, same thing, same thing. Yeah, we're going to end up with 10 carets. And they're going to have indices 0 through 9. So they're going to be named 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll have 10 carets in our little vector box. Okay? And this is a common way to write for loops, especially for vectors. Okay? So we can copy and paste it a lot, start to get familiar with it. Okay? It's called iterating through our vector, or iterating through the loop. Okay? And so we're going to make our vector of carets that way. Okay? Now this doesn't actually add our vectors to the stage. This just puts them into that vector for us, into the box for us. Okay? We're going to use 2 more variables to help us out by putting carets to the stage. We're going to use a counter variable to count how many carets were put to the stage, and then a caret num variable to count. Actually, the counter variable doesn't count how many carets. The caret num variable counts how many carets are on our stage. And then we're going to write this function here. Okay, so let's just go through it really fast, and then we'll write it together. Now this is one of our bigger functions, probably the biggest function we've written so far. Okay, but let's understand what it's doing, and when we write it together, we'll put comments in there. But let's just look at it. Don't be afraid of a lot of code. Okay, but what we're going to do is we're going to put random carets. You know, we don't want it to be too structured. So we're going to use a rand variable, and you can think of this as a magical line of code, but pretty much it's getting a random number, The random number will be less than 1, so we multiply it by 100 to move the decimal place over. It gives us a decimal value. You multiply it by 100 to move the decimal place value, or the decimal over 2. And then we add 100 to it, because we have a counter here that's going to count 1 every frame. And when that random variable stays less than that counter, we'll add a caret. Okay. Plus, we're keeping track of how many carets we're adding to our scene so that we don't add too many. We only have 9 or 10 of them. So we don't want to go outside the bounds of our vector or add too many carets. Okay. All right. When we add a new caret, we set our counter back to 0. Just so you know, when we made our vector, we called our vector carets. That's the name of our box or the name of our vector. And so when we want to bring up a single caret or call upon a single caret object, we just want to say, hey, I want caret 0 or I want caret number 1. This is how you write, okay, this kind of code. You put the name of the vector, and then you put these square brackets, and then you put the index number in here. So if I wanted to bring up caret 0, I could put a 0 right here. And if I wanted to bring up caret number 1, I'd put a 1 right there. Now note that I did have a variable right there. And the reason being is so that I could go through and do this for all of my carets. Okay, or as I'm making them. Okay, so that way it's not hard-coded just for caret 0. Okay. Well, anyway, so I take caret 0 or caret 1 or caret 2, I take its x value, and what am I doing here? I'm taking the stage's width, and I'm adding, what did I do right there? Oh, his width, actually it goes off the side of the stage here. So what I'm doing is I'm setting his x value so that my caret will appear properly on the stage. Okay, this will make him appear at the top. Okay? Actually in the middle. So in the middle, stage x value is horizontal. It makes him appear at the end of the stage so that he can scroll in. Right? Stage.width is the end of my stage, adding the caret's width on there, so he'll appear right outside the end of my stage. And then I add a child at, so I add him at, okay, so he'll appear on the right layer. Okay. I then take my caret's x and y value. What did I do here? Actually, I think I repeated some code right here. Probably didn't need this line of code. But then I set his y value. You set his y value to the height of the stage minus the height of the caret. And then I add the second caret. Oh, I see. That's what I did. This was for our first caret, and this is for our second caret. Because remember what we're doing. We're adding 2 carets at the same time. We have one at the top and then one at the bottom here, so that they'll come together. Okay, so that's how we add our carets. We set their x and y values, and then we add them to the stage. All right, and then we'll make them move across the screen by using some code like this. So we make them move across the screen the same way we made the buildings move across the screen. Except we have multiple carets, and so when we have multiple carets, we have to use a for loop to go through and change all of the carets' x values to -6 so they'll all move together, you know, across the screen. All right. And then we'll check to see if it hits the bunny right here. And we do that with a hit test object function that's already written for us. And so if a caret hits a bunny, it fires an event. Okay, we can check to see, hey, have you hit a bunny yet? If you have, go to and play or go to and stop on our dead frame, and then we'll remove the actual hop function so they can't make him hop when he's dead. Okay? He can't hop anymore when he's dead. All right? So ready? Let's write this code. And yes, I am going to make you write it. I thought about giving it to you guys, but I think if we write it once, we'll write it nice and slow together. And we'll add some comments as we go so we'll understand it. All right. So first things first, let's make our vector of caret. Actually, let's make our caret object first so we can make a vector of him. I did not give you the caret object, so we need to make it. A movie clip object. I did give you a caret PNG file. Now, if you've got your own, obstacle you want to use, you can substitute your own obstacle right now. Like if you found an obstacle you wanted to use, like a tree or, I don't know, a plane. And you wouldn't have to use, the same on top and bottom. You could use a plane up here and a tree down here. Okay, you could do it differently. All right. What we're going to do is we're going to take that caret ping, drag it to the stage. It's a little large. So I'm going to use my free transform tool over here to make him a little bit smaller. If you hold down your shift key, you'll change the height, the width together. You don't want it too hard. All right. Now it doesn't matter where you put him on the stage actually, just that he's pretty much the right size. And then all we have to do is make him into a movie clip so that we can add him through our code. So just F8, name it caret, or whatever you want to name it. The only rule is that you start with a capital letter when you name these because they are class names. And then remember to say export for ActionScript. Okay, so we name our object with a capital letter and export for ActionScript. And you should see it up in your library after you press OK. You should see it appear in your library as a caret object. And then you can delete that instance from the stage because he's saved as a caret movie clip object. So now we have our movie clip object. We can make a vector of movie clip objects. And I am going to cheat and copy and paste, but that's okay. Now we do usually group those together. I put it separate so people could see the code better. But we do usually write these things together. So this is the code I just added. In fact, we could even write some notes. I think this is a great time where we start putting some notes to ourselves what we're doing. So we're making it's called a data structure or a vector. You can think of it as a box to hold all of the caret objects. Okay, caret objects. Okay. And to create a vector, we usually do it with this kind of syntax. So we name it like we do a normal variable with a lowercase letter. Some books will say that you have to name it with a singular noun, but I don't know, sometimes I use plural nouns anyway. Okay. And then the colon, and then a vector, and now we use our dot operator, and these things are called generics. And this just tells us that, hey, we're going to make a vector of caret objects. So if you wanted to make a vector of bunnies, you could put bunny in there. Or if you had trees, you could put a tree in there. What goes in these less than, greater than symbols, these generic symbols, has to be an object or a movie clip. Okay? Cool. And so that's our declaration of our vector, just like we declared our other variables. Now we need to instantiate him, or make him. So So we just looked at this code. Let's put it in there. So remember that we declare him outside of our constructor, and then it's in our constructor is where we instantiate or create him. So I'm just going to add him right after I instantiated the building. I put my bunny instantiation, and I put my building instantiation. And now I'll instantiate my caret vector. And we instantiate them the same way with that new operator, right? But this for loop here is what fills our vector with actual carets. When we make that new vector, he's empty. He's an empty box waiting for the carets to be placed inside of him. Think of him, as a box with holes in it for caret objects. But it's not until we run this for loop that it actually puts those caret objects inside of our vector. Okay, so we can even write some, you can write some notes in here to yourself. This is filling the vector with caret objects. And as you're copying it today, you might not understand all of it, but you will. The more you look at this code, the more it'll make sense to you. Okay. Just remember that this loop happens 10 times. It makes 10 caret objects. And it uses this function here, push, to push them into our vector. So it puts them into our vector. We push them in there. It's like pushing them into the box holes, right? Pushing them into our box. It's good to start visualizing stuff like that. You take a caret, you're putting it in the box. And you're putting 10 carets in our box. And remember, those carets are named 0 through 9. That's important to know that. All right. So we made our vector. We filled up our vector. Now, nothing's going to be added to the stage. Your code should compile and run still, so if you wanted to check the syntax, you could save it and do Control-Enter. He'll compile and run. He'll still run the same way. Notice that we haven't actually added our carets to the stage, so we don't see them yet, but they are created in the background, in our memory. Our caret objects are there waiting for us. Okay? But sometimes it's good to do a Control-S, Control-Enter just to check our syntax. Remember that in here, this one's a regular colon because we're telling it it's a number. But then to separate the parts of our for loop, these are semicolons. Okay, so 2 semicolons in the for loop. And then very importantly, there's no semicolon after the for loop. One of the #1 errors people do that I see in here is they put semicolon after the for loop. This will not cause a compiler error, but it will not work right. Okay, it makes our for loop happen 10 times and do nothing. Okay, and then we'll push 1 caret, and that wouldn't be good. All right, so just check your syntax out, make sure it compiles. And now we are going to write that awesome function. Oh wait, we need 2 more variables here. So we're going to make these 2 variables also. All right, so here's where we made our caret object. We're going to make 2 more variables underneath him. In order to get this code to work, we needed a counter to count when we wanted to actually add the carets to the stage. And then we needed this caret num to keep track of how many carets we've already placed on the stage, so that way when we've placed all 10 carets, we don't keep trying to place new carets to the stage. And there is different ways that you can code this, and my programmers, if you want to code it a different way, you can. Okay? This was just an easy way to code it. But I just kept track of when to put it on the stage with our counter and then how many were put on the stage with caret num. And those are both variables of type number, so they're just going to hold, an integer. All right, so we got our caret vector, our counter, and our caret num. And to initialize those two number variables, all we have to say is you guys equal 0 at first. So I initialized them right under where I initialized my caret vector. So this is in the constructor. This is where you want to do your initializations. They can go right here with gravity. Gravity was 0. We can make our counter 0 and our caret num start at 0. So that way when they're starting off, they have an initial value of 0. That's important for when we want to add 1 to them. They need to start out at 0 so we can add 1 to something. Okay? All right. So we got it all set up. We got our vector, we got our counter, we got our caret num. All right. So I kind of separated the code out. So we're going to write these two things on our frame enter event. Okay, so I'm going to copy these two. But if we go and look at our code, on the on frame enter event, now you could put this anywhere. And what this is doing, so I put it here on the on frame enter event so that it's happening 24 times a second. It's happening with our clock. Okay. And what I do is I added 1 to my counter. So it's counting the frames per second so it doesn't add a new caret, every frame. We don't want to add a caret every frame, and we don't want to add it at a set number of frames. We want to add them random. So if we wanted to do random, we need this counter to count the frames. Okay. And then this right here is actually a function call. So we put the name of the function. I made a really long function name, check counter and put caret. That's what this says, check counter and put caret. I used camel case to write that function name. I know it's a function because it has parenthesis, parenthesis, semicolon. So what we're going to do is we're going to encapsulate all of the check counter and put caret logic outside inside of its own function just to make our code nice and neat. We could write it all in here, but it's good to make a nice little function separate. Okay, so now we need to write this function. All right, we'll write the first part of our function first, and then we'll do the het test part. Now I'll leave this code up here for a while. Maybe this is a good place to take a break. Now remember, when you're making this new function, you want to put the function outside of any other function. This was why it was a good idea to name our curly brackets. But before the end of the class, so you want to put this new function, after any other function. It makes sense to put it after the on-frame enter function. But before your end of your class, put that function in there. Now, as you're writing this guy, you can make some notes and things. And actually, I need to put my ending curly bracket in here. And you can name that ending curly bracket. So as you're writing this thing, here's the beginning of my function, and here's the end of my function. Let me make more room up here somehow. There we go. Here's most of it. It is a longer function. To get it to work, we kind of do have to write it all out. Actually, if you wanted to test it as you go, well, And remember, as you're writing this, you could put some notes in here. So this makes a random number, right? So that our carrots will appear at random times. So, and I guess you could, you know, leave that part out, but it kind of makes it nice when they appear at random times. It makes it a little bit fun, you know, more fun. Any kind of randomness in a game. Okay. Games are built upon randomness. If your game worked the same way every time, it would be very boring. Okay, you ever think about that? Ever play a game without dice or with your cards in a certain order? That's no fun, right? Randomness is what makes a game. So we introduced our random. We'll use this random function again. Okay. But we're just using him to kind of make that random number that we called rand. We just named him rand. And so remember that the counter was counting the frames. Remember we added 1 to counter up above. So as long as that random number was less than our counter, then we would evaluate that statement as true. And we haven't already placed all of our carrots on the stage. And note that at the beginning we set our counter back to 0, so it's ready to count again. Then we add our first carrot.
Can you move to the right?
Yes, and that just says width at the end. This one was for width. So this is taking that current carrot's width, which are all the same. And note that I put width here instead of hard coding a number like, you know, I could have hard coded the number 400 right here, but it's always good to use the width of your object with the width variable, so that way if you go in and change the width, your game's not going to break, or if you change like your object and he's different, it has a different width, it's not going to break. It's good to use that width variable right there. Okay, I'll move it back this way. And remember, you can even add some notes in here. So this adds our first carrot, adds the carrot at the top of the stage. So adds, you know, the first carrot. And remember that this code down here adds the second carrot at the bottom of the stage. Remember that you can put more notes in there than I'm putting. Okay, you can remind yourself what this code's doing. And this code is more complicated. It might take you a little while to understand it, but remember that we read our code from top to bottom, and you can figure out what each line is doing. Okay, and you have seen these functions before. And then our last for loop here, it goes through all of our carrots that we've already added. So it goes up to caret num. And then it increases those caret nums, or actually decreases their x values, so it makes them move to the left. And again, you could play around with this number or make this a variable, and you can make your carrots move faster or slower by changing that number right there. So if you had different levels, if you made this a variable instead of hard coding 6 here, you know, at the higher levels, you could make your carrots move faster. You know, make it harder. That's how you could increase the level of difficulty in your game. Or if you wanted them to appear more often, you could play around with that rand variable. That would make them appear closer together. So you could figure out how to make your levels more difficult if you wanted to level up. That would be a good final project, to have 2 levels or multiple levels. I think I'll put this on pause for a little bit. And so once you get this one working, let me make sure mine works also. Actually, let me make sure I don't have any compiler errors. It should show your carrots. Yeah, there's my carrots. Now notice that if I hit my carrots, they're not making me die because we haven't told it to make us die yet. Okay, but they should eventually appear on the stage there for you. So I'll leave this code up. I'm going to pause this. I'm going to put the hit test up here. So then those of you who are finished, if you want to do your hit test, you can. It's actually a little tiny bit of code right here. You're going to put it with the other for loop. So let me copy and paste this back into our other code. So inside of this for loop where we're iterating through and checking all of our carrots and moving their x value, we can put this branch. So this is at the end when we're moving those carrots x values. And this little test right here will check to see. It'll go through our for loop and it's going to check every carrot, and every carrot it's going to see, are you touching our bunny? And because this happens so quickly, you know, it does check all the carrots, so it'll check all 10 of them, okay, within like less than a second to see if they're touching our bunny. If this comes back as true, then the way that we created our bunny is on his timeline we had a dead label. Remember we labeled one of his frames dead? You guys remember that? So just so we can remember, over here in our flaw file, in our library for our bunny, remember that we made this label here and we called it dead. Okay, so it's going to say, okay, go to this frame here and stop. And remember that on that dead, we gave him the dead look. Remember that? All right. So that's what this is saying. Okay, go to and play that, or go to and stop on the dead labeled frame, the frame that's labeled dead. And then this little function right here, remove event listener, takes away the listener that's listening for our click event. So then, even if the user is clicking, 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 it's not listening for that anymore. It will not do anything when they're actually clicking because he's dead. You shouldn't be able to make him hop anymore. Okay? All right. And I'll continue to come around and help debug, and we can get him working. And if you've got it working, you can change your character. So the requirement is you do need to change your character. It's actually pretty easy to change your character. Okay. And you could add even more functionality to this if you wanted to. Okay, you could have a score, you could have a reset button, you could have an intro screen. But I'm going to leave that for like a final project, but I have had students take this, you know, and make it a little bit different. I'm going to pause